for example, let's say that I start at point A. Okay, let's say I start at point A, and I'm like, okay, if I want to go to point B, if I want to go to point B, I have an enthalpy change of, let's say, plus 30 kilojoules per mole, right? Then let's say from point B to point C, okay, I have an enthalpy change of, let's say, another plus 25 kilojoules per mole, right? And then let's say that I go from point C to point D, okay, I go from point C to point D, and I have an enthalpy change of, let's say, minus 15 kilojoules per mole, right? Now, what if instead of going about this entire process, I went directly from A to D? What would the enthalpy change be? I can go plus 30 plus 25 minus 15, or I can go directly from A to D, which would simply be 40, right? 30 plus 25 is 55, minus 15 is 40, right? Plus 40 kilojoules per mole. So this is the idea. The idea is that I can go from A to B to C to D, or I can go directly from A to D. The enthalpy change for either of these processes wouldn't matter. Because why wouldn't it matter? Because we have the same starting point and the same end point. That's essentially what Hess's law is saying. Okay. So what Hess's law says is, okay, Hess's law says, so this is Hess's law, okay, it says that the enthalpy change of a reaction is independent of the reaction pathway, okay, as long as the initial and final conditions are the same. As long as the initial and final conditions are the same. Okay, so reaction pathway ke liye you can say route taken also. But the point is, as long as the initial and final conditions are the same. Why is this important? Well, if you're going from A directly to D, let's say, or you're going, let's say, A to B to D, or you can go A to C and then D, whatever. As long as your initial and final states are the same, the enthalpy change for the overall processes are the same. Now, the initial and final conditions also have to be the same, right? Because agar conditions same nahi hongi starting or ending mein, तो फिर obviously A और D की energies affect होंगी. So in order to be able to compare the two different cycles, we want to make sure that in both cycles, A was at the same energy and D was also at the same energy. So we have to ensure that the initial and final conditions are the same. Doesn't matter what route is taken, as long as the initial state and the final state are at the same conditions, right? The overall enthalpy change will always be the same, right? So here, let's look at a following example. So here the question is saying, from the following cycle, find the value of the conversion of carbon to carbon monoxide. Alright, so what you can do here is, let's say you assign this a value of x, right? Now if you start at carbon, you can go to carbon monoxide and then to carbon dioxide, or you can go directly from carbon to carbon dioxide. So we can say that the overall enthalpy change for this path, right, is the same as the overall enthalpy change for this path over here, right? And so you can say that x minus 283, that's the path I've highlighted over here, is equal to minus 394. And therefore x will come out to minus 111 kilojoules per mole, right? Now just like vector diagrams, there's multiple ways to solve this. Well, one way, but multiple ways you can represent this. Let's say you wanted to find x directly. Well, you can say, you know what, if I want to find x, that's carbon to carbon monoxide, that's the same as saying that I go from carbon to carbon dioxide and then carbon dioxide to carbon monoxide. carbon dioxide to carbon monoxide would simply be plus 283, because the backward reaction ka enthalpy change is just the negative of the forward reaction. So again, you can say that X would simply be carbon to carbon monoxide is X is equal to minus 394 plus 283, and that would still give you a minus 111. Okay. So next example that we have is this. Calculate the enthalpy change of the following reaction using the data given. Right? Now what we have is, you essentially they want you to find the enthalpy change of vaporization of water. You're converting liquid water to steam. Right? Here, whenever you're faced with, whenever you have such a question, right? जो भी आपका unknown enthalpy change है, जो भी आपका unknown enthalpy change है, यहाँ पर liquid water to gaseous or water which is steam, right? Now what you would do is you would put your unknowns in the first two boxes. Okay, so what you have is H2O liquid being converted to H2O gas, right? So this is your unknown, which is X, right? Now in the last box, if you notice, they both have the same reactants. So in the last box you simply have the elements, right? You have H2 gas plus half O2 gas, right? Now the conversion from hydrogen gas and oxygen gas to liquid water is minus 286, that's given here, and the conversion from these gases to steam is minus 242, right? So then I can say that, you know what, if I started from the elements, I can first form liquid water and then steam, or I can start with the elements and directly form steam. So I can say that this path is equivalent to this path, right? So I can say minus 286 plus X is equal to minus 242, and therefore X is equal to plus 44 kilojoules per mole. So that's our answer. So that's the enthalpy of vaporization of water. Alright, so here we have the following. Calculate the enthalpy change of the following reaction using the data given below. Okay, so over here you can say that, you know what, you're starting with BRF, okay, you're converting BRF to BRF5, right? So that's your overall enthalpy change that you're looking for. Okay, let's call that X. Okay, let's call that X. And now you can either go directly from BRF to BRF5, or you can first convert BRF to BRF3 and then convert BRF3 to BRF5. Okay, F2 को मैंने हटा ही दिया. It doesn't, like, it's just to show the energy cycle. That's the idea here. Like, you don't have to think about balancing the equations here. Alright, balancing, we'll see where balancing is going to be useful here. But you clearly just have to, over here we clearly have 1 mole of BRF, 1 mole of BRF5 and 1 mole of BRF3 in this entire cycle, right? So what we have is that if we convert from BRF to BRF3, our enthalpy changes minus 242, that's the first reaction. And then from BRF3 to BRF5, our enthalpy changes minus 158, right? So this path over here, which is the overall enthalpy change, you can go directly from reactants to products, or you can first convert the reactant over here to some intermediate, which is BRF3, and then convert that intermediate to the final product, right? So what we have is X is equal to minus 152 or 158, sorry, or minus 242 minus 158. So therefore X is equal to minus 400 kilojoules per mole. So here's the next question. Calculate the standard enthalpy change of combustion of methane from the following data. Okay. So now they've given us enthalpy changes of formation of carbon dioxide, H2O and methane. Alright, so over here the first thing you should do is you should write down the equation that represents the standard enthalpy change of combustion of methane. So that means that clearly we should show that 1 mole of methane is being combusted, right? तो ये हमने balance कर लिया पहले से ये part. Methane का 1 mole ही होगा, right? It reacts with oxygen to form carbon dioxide and water, right? Now carbon dioxide का सिर्फ 1 mole बनेगा because we still have this one carbon atom. H2O कितने बनेंगे? 2 mole. तो oxygen कितने हो गए? 4. So we have 2 O2, right? We have 2 O2 here. Now, whenever a question gives you formation enthalpies, formation by definition means that something is being formed, a compound is being formed from its constituent elements. So over here, methane is being formed from carbon and hydrogen by this enthalpy change. Carbon dioxide is being formed from carbon and oxygen elements, and water is being formed from hydrogen and oxygen, right? So in the third box, what you would have over here are your elements. So what you have is carbon, you have oxygen, right? And you have hydrogen, right? And I've balanced them here, but you don't have to. So this is what your cycle looks like, right? Now, so whenever you're given formation data and you have to find the enthalpy change of any reaction, you will always have the elements in the third box. Okay, whenever you're given formation data like they've given in this question, you'll always have elements in the, so your 2 unknowns, right? So now this is your X. This is what the enthalpy change you have to find. Now they've given us formation of methane. Agar formation of methane minus 74, where does the arrow go from? The elements or where's the starting point for this arrow? Elements to methane, right? So this is, over here, you have elements to methane is minus 74. By definition, oxygen gas to oxygen gas is just 0. Formation of elements is just by definition said to be 0, right? And then carbon dioxide के लिए क्या है value? Minus 394. And water के लिए क्या value लिखेंगे? Twice. So by definition, so by definition, formation of water is for 1 mole of water. In this particular example, we're forming 2 moles of water because ये तो हम लोग का fixed balancing थी. We have to find it for 1 mole of methane. अगर 1 mole of methane combust हो रहा है तो पानी कितना बन रहा है? 2 mole बन रहा है. So that means कि we're gonna have 2 times the formation of water. Minus 97. Okay. So what we have here is, you can simply say minus 74 plus X. You can go from elements to reactants and then combust, or you can go directly from elements to combustion products, right? So what we get here is minus 74. We get minus 74 plus X is equal to minus 394 plus 2 times minus 288. So अब X की value क्या आती है? So when you solve for X over here, what you get is X is equal to minus 896 kilojoules per mole. So that's our answer. Alright, so the next question that we have is this. Given the above data, okay, what is the enthalpy change of the reaction shown? What is the enthalpy change of the reaction shown? Now, they've already given us the 2 equations, right? Or they've given us the equation that we have to solve for. So what we have is, we have this equation here, where carbon monoxide and iron 3 oxide react, okay, to form carbon dioxide and iron. So now we have to find this enthalpy change here. That's our unknown, right? And we know they've given us again formation enthalpies. They've given us standard formation enthalpies for all the reactants and products, right? So now over here, what do you think comes in the third box? Just elements, right? So you don't even, so you can, they will accept you saying elements. Okay, so you can just say elements over here. So in the third box, we have the elements, right? Now, हमको दी हुई है कार्बन मोनोऑक्साइड की फॉर्मेशन क्या है -111. But again, they want us to find the enthalpy change of the reaction as it's shown. As they've balanced it, they want us to find that. Right? So carbon monoxide के हम कितने मोल बना रहे हैं यहाँ पर from the elements? 3. So that would be 3 times the formation of carbon monoxide. Right? Similarly, iron 3 oxide के हम कितने मोल बना रहे हैं? 1 mole और इसकी formation दी हुई है -822. So that's -822. कार्बन डाइऑक्साइड के कितने मोल हैं? 3 है. So that's 3 times -394. And iron solid की क्या होगी formation? 0. By definition is just an element. So the form you're just going from iron solid to iron solid. So that's 0. So your starting point, whenever they've given you formation data, your starting point is the elements and your ending point is the products here, right? So what you have is you can start from elements, go to reactants and then to products, or you can start from elements and directly convert the elements to products. Those are your two cycles here. So you can either go here directly or you can go indirectly from elements to reactants and then reactants to products. So what you have is 3 times -111 plus -822, right, which is -822 plus x is equal to 3 times -394. X is coming to -27 kilojoules per mole. Okay, and that's our answer. All right. So in general, for example, if let's say that we have any reaction, okay, in which reactants are being converted to products, right? And let's say that the delta H for this reaction is just delta H of the reaction, right? Now, and let's say it's carried out under standard conditions, right? Now, if they've given you enthalpies of formation, right? If they've given you enthalpies of formation for any given reaction, you can say that our elements are the starting point, right? And you can always first convert the elements to the reactants. That would be the sum of the does everyone know the sum formula, right? That would be the sum of the enthalpy changes of formation of the reactants, right? So the elements can be converted to the reactants and then the reactants can be converted to the products, or elements can directly be converted to products, right? Or elements can directly be converted to products. So that's delta H for that. Any time formation enthalpy or whenever formation enthalpies are given, you can use this idea, right? That elements can first be converted to reactants and then reactants can be converted to products, or elements can be directly converted to products. So what that tells us is that the formation of the delta H formation of the reactants plus the enthalpy change of the reaction itself is equal to the formation of the products, right? Again, elements to reactants and then reactants to products, which is reaction, is the same as saying elements to products. So therefore we can say that for any given reaction, the enthalpy change of that reaction can simply be said to be the formation of the products minus the formation of the reactants. Okay, and this is going to be a very, very useful formula for MCQs. If they've given you formation enthalpies in an MCQ question, okay, it's simply the formation of products. For any given reaction, the enthalpy change is simply formation of products minus the formation of the reactants. Okay, and we see this example here as well. So if you notice in the previous example that we solved, right, what did we see here? So what did we see here? Over here we had formation of reactants, right, which was 3 times -111 -822 plus the formation of, plus the reaction itself, is equal to the formation of the products. So if you just subtract reactants from products, or subtract reactants from products, you get the enthalpy change of the reaction. Make sure that, but just be clear on this कि अगर आप carbon monoxide की formation ले रहे हैं यहाँ पर, make sure that you use the stoichiometric coefficients, right? यहाँ पर 3 मोल है carbon dioxide के, so you take 3 times formation, right? So that's the idea. Okay, so this is the equation that you can use to find the enthalpy change of any given reaction. Now, if a question asks, in structured questions in P2, most questions will actually ask you to draw the energy cycle. Most questions will ask you to draw the energy cycle. It will specifically say draw an energy cycle or draw a Hess cycle to calculate the enthalpy change. But if a question doesn't ask you to draw an energy cycle and they've given you formation data, or like an MCQ for example, then you don't have to draw the energy cycle. If they've given you formation, you can always just say that the enthalpy change of a reaction is the formation of products minus reactants.